Hi everyone, I am Vishnu Prakash. I am presenting you a student portal using Flask microservices and React.js TypeScript UI. So it is also using a MongoDB database. Now the world has changed its course from monolithic approach to microservices based software engineering to handle multi-platform containerized applications. We know that most of today have different kind of even platforms, kind of like Apple TV is there, tvOS is there, Android is there, and mobile phones like with different OSs, and even our fridge have its own applications, IoT kind of applications and everything. Android based electronic appliances are there. So in order to communicate between all these things, we need different kind of softwares and different language technologies. So to communicate in between them, we need to create a microservices based architecture. In this presentation, I am going to show you a portal designed to handle student related operations like registration and creating a finance and library account, paying fees, enrolling and graduation of courses. So for that we use several languages and architectures which uses OOPS concept to create microservices. So here are the links for the GitHub accounts. Like here we have 4 applications that I have developed. One is student portal UI basically designed in React.js, and there is a student portal Flask API. So that actually access the rule engine to do the stuff related to student portal, and there is a user management API with a intention of creating a separate architecture just for user management and authentication. It is using a JWT token access control, and the data JWT token is saved in Redis DB, and we created an API gateway in order to communicate with all these APIs and with the TypeScript one. So I will explain it later in this presentation how the software is built and all. Our aim is to design a fully functional system to carry out operations for a student portal using microservices architecture with a Python Flask, and the database is MongoDB, and we use React.js TypeScript for the UI. So our objectives are go through the literature to find out how this thing is done and to plan a solution that create an architecture to register, login, enroll and graduate a student. Also there are options to pay the fees online and handle the library as well. um, to program the microservices using Python Flask, and we used Docker to containerize all these applications. To program the rule engine to check eligibility to graduate and add fees and communicate with finance and library modules. To implement database to store data and pass variables to service. So obviously we have to save the data that is being handled. And finally to create a industry ready system. I can't say like industry ready, but this is kind of like having a lot of applications in future. So you can see the architecture is like this, and API gateway acts as a middleware between the UI portal and the backend app. So what happens is this API gateway have all the information of all the APIs, and it have the API key, and it communicates with all these based on the URL we gave. We don't have to like go through all the APIs to link together, and there are different databases associated with the different apps. So we have 4 apps here. User management have a separate DB, student app have a separate DB, library app has MariaDB as the database, and user management and student app is written in the Flask API. Library app was also written in Flask API, but by another person, and finance app was written by our professor, which is in Spring Boot, and it has a MySQL database. Library app also has a MariaDB database, and the rest of the app have MongoDB. So the API gateway is written in such a way that it can handle put, post, and API using JSON as well as data kind of path. And we have 3 portals. One is student portal and another one is library portal, where you can borrow the book and stuff, and finance portal We don't use finance portal here because we already got the student portal to do the finance operations as well, but finance portal can be used to like as an admin tool to add fees and all. In future we have given the provision to add such things. So the database used here is having like MongoDB. We have three databases in single server. Instead of creating three servers, we used a single server to handle this. So here you can see we have API portal database which saves the API. So these are the API URLs, like we have used the IP address and the port to communicate between all these ones. Uh, but the thing is, we already know it is identified using the service based thing. So this is the student service API, and it has a key, and we have user base or user management system, which uses this API key, and almost all the stuff is written using like this architecture. So the communication between all these four portals is done using this API gateway. Here we have the user management database which holds uh, details of the student, where email, password and student ID is saved. We have student portal DB, which holds the data of all the courses, enrollment details, and the invoices. And we actually created a numbering system that automatically numbers the student ID and enrollment number. We have student details also saved inside this database. So we have a React.js TypeScript UI, which is actually written in TypeScript, React.js TypeScript. Uh, Here you can see we have like a app.tsx, that is the base gateway to the portal, and from here we have used routes like login, register, dashboard, my course fees and sign out. That actually comes from the components here. So let's say login, this is the login script here. So login have like API, an API call that goes to our API gateway. So it uses access token and refresh token to actually identify the person, and the operations are carried out using that. So here API we use Axios. Here the Axios handles all the API calls, and we mostly use the post one, and the token is sent as authorization token here. So we used Access for RESTful API handling, and styled components for styling, JWT tokens for authentication, and Bootstrap 5 for designing. And we have API gateway here, as what I have said earlier. We actually uses this API gateway to communicate between different portals and different backends. So here you can see we use the dynamic path based application, where we identifies the service that goes to the database, and here the database actually takes out the path, and it pings the path using all the data we already got um, uh, from the API call. So we have, if it is pure RESTful API call, like if it is a JSON call, it uses JSON function to handle out the task. And if it is a data normal data string kind of call, then it uses a data call. So that is identified using the header type, content type, and the process is carried out. So here, after API gateway, what happens is like uh, the system goes to each and every portal, and that is actually handled using main.py. So these are all the parts of API calls. And for like registration and actions, we use post. And for dashboard kind of stuff, the data we use get and post. So the application uses different kind of uh, structure to actually goes through this app function. So let's take how the fees route is handled. So here we have all fees function where we call gets a X API key and the referrer, and we verify the API key using this function, verify function. So in the API, in the verify function, we have already taken a created a JSON file here, which says a API key that is meant to be communicating, and it has a referrer. So it always happens to be like it always happens to be the request is from gateway. Direct requests are not accepted. Also, this thing is actually inside a private network, so only API gateway is exposed to the public. That we will be discussing while discussing about the Docker. So here you can see there is a API key and the referrer here. It checks with whether it is from the gateway, and if it verifies, then from the fees module, from student package, from fees module, we call the fees class and all function. So this is the fees module. So here what happens is we have used inheritance to actually handle the API functions. And here we get the like MongoDB is used to get the invoices using current user, and the response is saved like the response is having an array. So we use the enumerate functions from fees data, and we get the reference, and we pass that reference to check is it paid invoice, whether the invoice is already paid in the finance portal. So we go to sorry API call in the parent module. So here we go to check is paid. So here you can see the reference ID is passed, and we already passed the ID of this invoice as well. So we call a API. Here the finance, from the finance module, by the invoices, by the reference, and the reference number is passed, and we load the response. And if the response is paid, we actually change the status of our invoice as paid as well inside our local DB. Why we use the local DB is because we can't get the invoices by the student ID in the finance module. I think that would be a better choice if we had an option to like get all the invoices based on the student ID. And I could have written, if it is like I got a little bit more time, I was thinking about writing the function in Spring API. So here we use other kind of like register as well. In the register, we actually, when the user is registered, the data is stored, the student data is stored in the student database, and there is a user register function that actually calls the user management API, and saves the email and password there, and type of user as well. So and we create a finance account using the same student ID and a library account using the same student ID. So we provide the response like what are the data we have already inserted and stuff back to the portal UI. So we use Docker to handle all the stuff, as you can see uh, in the screen. uh, Sorry, yeah, in the screen we have the Docker installed. We have Mongo as the database that is exposed to public, and we have University API, that is the API gateway we are using, that is exposed with 5001 port, and Rust are not exposed because student portal user and user management is like the internal network kind of application. So only university port API, like this API gateway, can communicate with these two APIs. So we have finance stack as well here, where like professor's finance app is installed and the MariaDB database is there. This communicates with uh, the university API gateway communicates with finance app using the internal network rather than the external one, because here what happens is the call is based on localhost 8081. When we call the localhost in any of these applications, it like this container will call inside the same containers only. So we can't communicate with outside containers, so we have to use an internal network, bridge network, to handle that one. So library portal also have like a port 80, we have library app, that we will be discussing about those things when we check the application. So now I have discussed all the architecture and how the software is written. Now let's go to the portal and see how the system works. I will register a new user. You can use the date picker, but I would say it is easier for me to. I use the same university email and password. So when I click register, so my data is already inserted, and I got a finance account, as well as I got a library account as well. I can actually use this student ID to log into the library portal. So default pin is 000000. Here you can see all the books that is available, and we can borrow any book we want, kind of stuff. All the activities can be taken off. We have to like add the access control kind of stuff for this application, but I think we don't have that much of time, and I didn't do the date formatter function here. It would be better if we actually go for a formatter. And we have the course details here. I haven't enrolled for any of the courses, so there will be no fees here, and my course details also won't be here. Anybody can enroll from here, or from my course. I would say I would do that from like, on the from the database, no, dashboard. So I chose my subject, that is advanced computer science, so I am enrolling for the course, and I got an enrollment number, so all the details I got. And it says not graduated because uh, there is a application, like we just enrolled for the course, right? So after that, let's go to my course. All the details are here. So here we have, see, my student ID, my name, my email, my all other personal details, and we have the enrollment number here, and the degree I am studying, and how much fees I have to pay. Here for the graduation, it says please pay outstanding fees to graduate. So if we go to fees, we can see there's a reference fees that needs to be paid. So if I take the reference here and goes to finance module, okay, payment portal. You can see the payment that needs to be made, and due date is 17 May, because 10 days extra I have added stuff. So it is outstanding. I won't pay from here. I will go to my student portal, and there's a pay button here. So let's see. I click the pay button, so it's paid. So if you go again to the payment portal, find invoice, here it is paid. So the communication is done using the API gateways. So here when I go to my course details, yes, here you can see my graduate button is open, because I am eligible to graduate. So I have paid the fees. When dashboard comes, not graduated, the whole details is there. And here I have a book borrow. I have to return that. I haven't done any kind of like or authentication stuff, a credential check whether the book is returned so that he can graduate, kind of thing. We can add that kind of application if I got a little bit more time. So if I return this, there's no overdue, so here there will be no outstanding. So he is okay with to graduate. So I would say, like, let's graduate. He's graduated. So this is the whole application. We have done like most of the API calls were done using enroll data. Here you can see the response, enroll details, and we use flags to handle is graduated kind. And in my course also we have all the data required to display all the stuff, like is graduated, it is true. If he is paid, it's true. That's why we had a graduated. If is graduated is false, and is paid, if he is paid is false, then what happens is, like, there will be a red message that we already saw, that says please pay the outstanding fees. So This is my whole application. I wanted to do much better, but like I can show the here the invoices by student ID. If I instead of getting all the accounts together and checking for all the invoices together and checking for the student ID, instead that we can use SQL query like uh, a query that gets all the invoices by student ID. So even though it is possible, we used like another API. So we didn't get much time to do that. And here for the student portal and all the Flask applications I have done, I use PyMongo to as the uh, ORM. Not ORM because this is a document related database rather than relational database. It is a document oriented database. So we used PyMongo as a kind of ORM to handle uh, communication between database and the backend. And from backend to the front end, we use the API gateway we already talked, and it uses get function to find. I closed the serve. Actually, I commented self to server.close because from Python version 3.11 and PyMongo 4, what happened is like these all the functions became asynchronous. So as the function is asynchronous, what happens is server closes before the query is executed. So it throws an error. So it actually closes the server after the execution dynamically, so we don't have to use the server one dot close function there. So we already written a library kind of thing to get find. We can use aggregate. I thought like I can use aggregate, but we didn't have much purpose for aggregate functions in this. Aggregate is basically the join in SQL, but aggregate has more functions than join, and it is not as easy as join in SQL. Put is insert one. We can insert many. Put many function is written for insert many data inside into a collection. And set is update, basically update, and inc is used to get the data along with incrementing a field or a column inside the database. Set many means update many, just like instead of updating one, we can update many. And get one is find one. Get after count is getting one after increasing, but increment is just incrementing the data. It doesn't returns any value. So remove element is just deleting the data, that's all. Deleting a single object inside the collection database. So this is how all the stuff is done. Thank you.